The next thing we're going to cover is the identity matrix. And the identity matrix is similar to the last matrix that we looked at, the main diagonal, in that we have ones across our main diagonal, but now notice that we have zeros above and below it. And the reason this is called an identity matrix is because it's going to give us the exact answers to the problem. So notice that this has x and only x. So this is x equals a. This one only has y. So y equals b. And this one only has z. So z equals c. The identity matrix is a very simple way to find your answers immediately. Now, we're going to talk about Gauss-Jordan elimination, which is similar to Gaussian elimination, except we do it all in the calculator and it'll take about 30 seconds to do the problem after we set it up. So, just like the last problems, we want to write this as a augmented matrix. So I'm going to write my augmented matrix. And we have 31, 19, and 25. Notice this is the same problem that we looked at before, and I'm going to show you how much faster this is than the other method. So we have this to start with, and we have our calculator on the right-hand side. So on the calculator, we're going to press second matrix. Now when I press second matrix, it comes up with a bunch of matrices. A, B, C, this is the name of each of those matrices. Now what I want to look at is I want to scroll over to edit, and I want to edit matrix A. So we're going to call this matrix A. So we're going to go over to edit, and now it's going to ask me, how big is your matrix? Remember, it's rows by columns. So I have 1, 2, 3 rows, so 3, enter, by 1, 2, 3, 4 columns. If your matrix doesn't look correct, that means you've put in the wrong dimensions. So now we're simply going to put in the numbers. 3, 1, 2, 31. Notice there is no line, and that's okay. 1, 1, 2, 19, 1, 3, 2, and 25. Enter. Now, I want to make sure before I get busy doing my calculations that I've put everything in correct. So 311, 113, 222, 31, 19, 25. Everything is in correctly. Now I press second mode to quit, and now I want to do the Gauss-Jordan elimination. Now, Gauss-Jordan elimination is where we're going to take the matrix, and we know this is matrix A. I'll write this up here. And we're going to do what's called the reduced row echelon formation, or the reduced row echelon. So we're going to go back to second matrix, and this time we're going to go over to math. And when I scroll down, we'll find it eventually, there's an REF and there's an RREF. We want to use RREF. So we're going to press enter. Now we have to tell it which matrix to do this with. So we're going to go back to second matrix, and we want to use A, which already says it's a 3 by 4, so we simply press enter. Now it tells me it's going to do the reduced row echelon form of matrix A. When we press enter, we get our matrix. So I'm going to copy this matrix onto what we have right here. So we have 1, 0, 0, 6, and we know that's a line there. Then we have 0, 1, 0, 3, and 0, 0, 1, 5, which tells me x is 6, y is 3, and z is 5. So I hope that you like this much better. It's much simpler, and you always come up with the correct answer as long as you put everything in correctly. We're going to look at one more example of how to do this, and I'm going to show you how to clear that out, or you can use a second matrix. Again, the very first step we need to do is write it in an augmented matrix. So we have 2, 1, 1, negative 1. So we have Wx, which is 1, negative 1, negative 1, 2, y, which is 3, 2, -1, and -2, and -1, -2, 1, and -1, followed by 6, -1, -4, -7. Now, if we tried to do this the other way, we'd be here all day. That's why this is so nice to be able to use the RREF, or the reduced row echelon form of our matrix. So we're going to call this one matrix B now. So we're going to go back to second matrix, and we're going to go over to edit, and this time we don't want to edit A, we want to edit B. So we're going to go down to B. And now we have to figure out the rows, 1, 2, 3, 4 rows, the number of columns, 1, 2, 3, 4, 5 columns, and again we're going to put in our information, 2, 1, 3, -1, 6, 1, -1, 2, -2, -1, 1, -1, -1, 1, -4, -1, 2, -2, -1, and -7. Enter. Now, just like before, I want to make sure I'm not making any mistakes. 2, 1, 1, -1, 1, -1, -1, 2, 3, 2, -1, -2, -1, -2, 1, -1, and 6, -1, -4, and -7. So we exit out. Again, we're going to go back and do the reduced row echelon. So we're going to go back to second matrix, over to math, and instead of going down over and over again, I just pushed down so it gives me the bottom of the list. There's my reduced row echelon form. And this time I want to use matrix B. So I simply go down under names and use matrix B. And it pops back an answer. And the answer is the matrix 1, 0, 0, 0, -2, 0, 1, 0, 0, 1, 0, 0, 0, 1. Oops, I made a mistake. I got carried away. 1, 0, 4, and 0, 0, 0, 1, 3. So remember, we started with W, so W equals -2, X equals 1, Y equals 4, and Z equals 3. And this is the complete version of everything you'll need to know to solve by Gaussian elimination and Gauss-Jordan reduction.